Hello guys, in this video I want to show you how to create some procedural stitch on Houdini. So in my case I will use a shoe as an example for this video, but you can use any model. So for example you can use a bag or anything else. So if you want to download this 3D model with the texture sets and the source file of Houdini, you can check the link in the descriptions. So let's start with the beginning in Cinema 4D. So I have my 3D model here, and the first step is to check a reference. So I will show you the reference I have for this specific shoe. So I have my reference image for this specific shoe model here, and you can see we have the stitch on the white part here, and you can see the back of the shoe. We have some stitch here also. So the first step on the 3D model is to add some edges on the position of the stitch. So we can visualize the topology by clicking on display, quick shading line here. So you can see here I've added some edges on the stitch position. So I have the edges here for this part, so the edges on the border here. So I have the edges in the middle here, same here, same here. And for the band here, we can see we have the edges here, and at the back of the model we have the edges on the side too. So if you don't have those edges, you can add them very easily. So in my case, I will remove that one, and I will show you how to add some edges on the position of the stitch in one click. So here I have removed my edges on the side of this part, and to add some edges here on the position of the stitch, you can simply double click on the edge here to select the loop. And here you can select the slide tool. So the slide tool is here, and the shortcut is MO. So you can just press Ctrl on the keyboard and you can slide the edges like this. So in that case, you can position the edges on the position of the stitch. So it's very necessary to make that step before going into Houdini, because we will use that edge later in Houdini to create some procedural stitches. So you have to make that step everywhere you want to add some stitches. So when it's done, you can simply export this model in FBX to import it into Houdini. So to do that, you can select the model here, File, Export Selected Object As, and in my case, I will use FBX. And here I will click on OK, and I will export it into the desktop here. So I can just keep the name as it is and click Save. So I've started a new blank scene into Houdini. The first step is to add a new geometry node. So you can dive inside, and here you can add a file node to import our model in Houdini. So in my case, I like to disable that tab here to get a bit more space. And here I can press P to open the parameter on the side here. And you can select the object by this little icon here. And in my case, it's on the desktop. So the first step is to create a group for the edge where we want to add the stitch. So to do that, let's add a group node. And here you can specify this is a group for the edge. So you can change the group type from primitive to edge. And here you can select your edges by these little icons. And you can go into the 3D viewport here, and you can select the different edges where you want to add your stitch. So in my case, I will select that one, for example. So here you can go at the opposite side. And here you can simply press Shift and A to select the loop. And you can see I have selected that one. So you can do absolutely the same for every part where we want to add some stitch. So I will select this one. And I will also select the middle edge of the top part here. So I will press Shift, and I will go into the opposite side here. Press Shift and A, and I can select the edges here. So I have all the edges for this part. So now I can select the edges of the band here. So I can press Shift and double click, and same for that one. Same for the opposite side here. And I can do absolutely the same for the back part. So I can select the edges here, Shift and A, and I can select the loop. Same for this one. So Shift, I can go at the top, Shift and A, and I can select the loop like this. And I can do absolutely the same for the side part here and the side part here. So I will speed up the video and I will show you the result later. So I have selected all my edges, so now I can press Enter, and now you can see we have created a group with those edges. So if you modify the geometry, you have to reselect the group, but this is not really a problem. You can do it very, very fast. So here you can rename your group. So for example, you can rename it something like lines. So now you can use a node called edge group to polyline here from Labs tool. And here you can specify the group you want to convert into lines. So in my case, I have called the group lines here. So I will select it here. Now I have my lines here and I can add some stitches into it. So here I can use a fuse node in case we have some points on the absolutely same position to merge them together. And now if we are looking the primitive number with the little icon here, we can see we have many different primitive here. So we want to convert them into one and single primitive for individual line here. So to do that, you can simply add the polypass node, polypass. And now we can see we have way less primitive number here. So this step is really important, otherwise it can cause some issue later. So now let's add a resample node. So with the resample node here, you can adapt the value for your specific geometry, but in my case, I will put the length here to 0.003. And I will also add the curve view attribute, so I will tick these little icons. So now I can transfer the normal attribute I have on my geometry here to the line created here. So to do that, you can add an attribute transfer. So you can plug the geometry into the second input of the attribute transfer, and you can plug the line into the first input of the attribute transfer. And here you can go into vertices and you can select the normal attribute. So here you can promote this attribute to the point. So let's attribute promote. And we can promote from vertex to points, and you can select the normal. So in that case, we have the normals on our points, and you can visualize them by clicking on these icons. And now we can see we have the normals on the different points here. So if you have some issue with the normals, so for example, here I have some issue in this particular part of my geometry, you can use an attribute blur to blur some normals. So let's add the attribute blur here. And we can replace the default position attribute by the N for the normals. And here you can select the proximity and disable these options. And here you can increase the blurring iteration to something like 300. And now you can see the normals are absolutely perfect now. So if you have some issue with the normal, just simply add an attribute blur. So now let's add a group range, group by range. And I will disable my normal visualization here. So in the group by range here, I can rename the group name. So I can rename it, for example, group points. And here I can change the group type from primitive to points. And here I will select, for example, 3 points of 40 in my case. But you can, of course, adapt this value now for your geometry, or you can adapt it later depending on the result of the stitch you want. So here you can also add an offset if you want, but I think it's not really necessary in my case. So now you can add a group promote. And here we can promote this group from points to edges. And here the group name is called group points, and the new name is group points. So we don't want to change the name for this group. And here we can use a dissolve node. And here for the dissolved, I will select my group called group points. And here I can keep everything else by default. So now we have this kind of result, and we can visualize the point number by clicking on this icon, and we can see we have huge amount of points. So we can add another resample node. And here with the second resample node, we can change the value from 0.1 to something like 0.005. And here we can check the curve view attribute. So now we can see we have this type of results, and we can deform this small line based on the normal. So to do that, let's add an attribute wrangles. And here let's create a first variable called amp, float amp, which is equal to a ramp. So in that case, we can define a profile for our deformations. So channel ramp, we can give a name to our ramp. So in my case, I will call it ramp. And based on the curve view attribute for each small line. And here you can simply multiply that by another parameter to control the amount of the deformations. So you can rename it, for example, scale. And now we can deform our line based on that. So at position plus equals at n for the normals, multiplied by our variable called amp. And now let's create that. Let's put the scale value here at something like 0.02. And here you can see we have deformed our line, but now we need to define a profile for our ramp. And now we can make something like this, for example. So now you can select all the points on the curve here, and you can change the interpolation to B-spline. So now you can also check the first one and the last one and put the value at something like minus 0.5. And the last one too, minus 0.5. And now you can define the profile you want with the curve here for the deformations to create some stitch. So I will create something like this. And now we can see we have some stitch here. So now you can add a measure node. And here for the measure, I will change the measure from area to perimeter length. So in that case, it will measure each individual line here. And I can add an attribute wrangles. And here in the attribute wrangles, we can run over a primitive instead of points because the measure node had an attribute called perimeter on the primitive here. So you can see the value of the perimeter attribute. So here we can create a very small vex condition. So if the perimeter value is below than a threshold, we can remove some very, very small lines. So to do that, you can add an if conditions. So if at perimeter attribute is below a threshold. So let's create a channel float for the threshold. So here you can simply remove those primitives. So to do that, we have a function called remove prim. And here you can specify the first input, which is 0, add primnum for all the primitive, and 1 to delete the points if there is some. And here you can simply close the bracket at the end. And now you can click on these icons and you can put the threshold at something like 0.02, for example. And I think it will be good like that. So now we can add an orient along curve. And now we can add the sweep node to create some geometry based on our line here. And for the sweep, we can simply choose round tube. So by default, the radius of the sweep node is at 0.1. So you can decrease this value, for example, 0.01. But of course, you can adjust this value for your own geometry. And here you can simply just change the scale of the deformation you want. So for example, I can increase a bit more to something like 0.3. 0.3, I think it would be enough. And here you can, of course, change the group range. So if you want, you can put 30, for example, and you can see the stitch will be a bit smaller. And you can put, for example, 5 here to get a bit more space between each stitch here. But in my case, I will keep it at 40, and maybe I can put it at 10 or maybe 8. I think it will be good like that. So in the sweep node, you can also add the UV and attribute, and you can compute the UV here. And I think it will be good for the sweep node. You can also close the geometry if you want. So you can go here and into the end cap tab, you can select single polygon. So in that case, you can close the geometry here with a single polygons. And I think it's pretty much it. And now you can merge those stitch with the original geometry. So let's add a merge node. Let's select the geometry from here and let's plug the stitch into the second input of the merge. And now we can see we have some very, very nice stitch. And I think the stitch in geometry looks really, really better than adding the stitch on a Substance Painter, for example. So I really like to make them in real geometry than in textures. So you can also add a name if you want for the stitch geometry to export them in FBX. So for example, if I check my original geometry here into the geometry spreadsheet, we can see we have a name here for different parts of the shoe. So let's rename my stitch here. So you can rename it ax.vance left, and you can give a name, for example, stitch. And now you can see we have a name for the stitch, and we have the name already made for the different parts of the shoe here. And here you can export your 3D models with the ROP FBX output. And here you can define a path based on the name attribute. So let's replace the path attribute with the name. And here you can simply click on save to disk. And in that case, it will export the shoe. And in that case, it will export the shoe with the already existing part plus the stitch we have created with the name. So in that case, you can get all the separate parts on Cinema 4D. So that's it for this tutorial, guys. I hope you enjoyed it. If you want to get the Houdini file plus the 3D model of the shoe, you can check the link in the description. That's it for today, guys. Thanks for watching, and don't forget to subscribe to our channel and check artivoxer.com to get premium 3D resources. See you in the next one. Bye.